Cryogenic temperatures are a challenge. They usually mean high upfront investment, tedious lab work, and are only accessible to experienced users. At kiutra, we have made it our mission to overcome these hurdles and democratize cryogenics. Democratizing cryogenics to us means that we want to make low temperature cooling simple, accessible for everyone, and scalable. We're using a fundamentally different approach to cooling. Instead of dilution cooling, we're employing magnetocaloric refrigeration to provide ultra-low millikelvin temperatures. So the use of magnetocaloric refrigeration essentially means electrification of cooling. It allows a high degree of automation, making our cryostats fast and easy to use. By avoiding limited helium-3, we also open the door for sub-Kelvin cooling at industrial scale. And this will be essential for the future widespread use of applied quantum technologies.
The L-type Rapid is kiutra's unique fast turnaround characterization cryostat. It employs kiutra's magnetic cooling technology to cover a huge temperature range down to now 50 milliK. In combination with our proprietary sample loading mechanism and extensive workflow automation, it is the fastest and most convenient system for Kelvin and sub-Kelvin characterization on the market. The L-type Rapid is compatible with a wide range of third-party components such as RF wiring, room temperature and low temperature electronics, as well as popular sample holder solutions such as QDevil's Q-Board and Q-Cage. This eliminates the need to develop custom solutions and helps reduce the time to first valuable results.
At kiutra, we have set up a dedicated cryogenics service infrastructure, which we call the cryofloor. This is a space in our Munich office where we operate several L-type Rapid cryostats, optimized, for instance, for the characterization of superconducting and silicon-based qubits. These systems can be rented by the users who can come to Munich to use them or access them via a remote desktop connection.
CryOFAS is a game changer for many users, including the growing number of quantum startups. They can benefit from quicker results, cost savings, or access to expert knowledge without needing their own equipment or staff.
One of our biggest challenges is characterization of qubit devices. And, when we build a fabrication run of qubit devices, being able to quickly test them and prove that they're actually operational is a big challenge for us and a big bottleneck in our ability to move forward as a company. The kiutra fridge, of course, with its high-speed change means we can go through 20-30 samples in a day and do very fast testing. So that's a significant bottleneck removal for us, and it's really a game changer and allows us to characterize devices extremely fast.
Kiutra is important for companies like IQM. They provide us a way to do rapid prototyping of QPUs, which enables our hardware development. And on the other hand, the cryogenic-free approach for cooling they pursue can be very beneficial for superconducting quantum computing, especially in a world where technological sovereignty and supply risks become highly significant factors. Companies like kiutra are important for the quantum industry because we need innovators who are able to adapt to rapid development cycles and are willing to develop and deliver industry-grade products.
I'm excited that we can contribute to a broad range of quantum platforms. This includes superconducting and silicon-based quantum chips, as well as trapped ion chips, quantum light sources, single photon detectors and V-centers, and a broad range of classical components. It is incredibly rewarding to us to see how our solutions help our customers and our partners to advance along their roadmaps. LEMON is a project funded by the EAC through an EAC Pathfinder Challenge grant. For the first time, LEMON will tackle the challenge of large-scale magnetocaloric cooling at extremely low millikelvin temperatures. Building on our proven technology, we are creating a viable alternative to helium-3 based dilution cooling, both in minimum attainable temperature as well as cooling power. The innovation will enable quantum devices to operate at extremely low temperatures independently of helium-3 supply.
Recent progress makes me optimistic to see practical applications of quantum tech in the next years. With our equipment and services, we would like to help accelerate R&D and use of quantum tech. We see ourselves as cryogenics partners for everyone who investigates, develops, builds, and runs cool quantum tech.